understand how to work a few problems before I turn you loose. We're going to do the notes, we're going to do the constructions, but you should have some time today to work on homework, okay? So it shouldn't take us the whole time. So that's a good thing. And remember, I'm not giving you another assignment today, right? Okay, so that's good. So, yes, I am. And you need the notes. That would be helpful, right? Okay. So, Riley Bell, do you have your signed permission slip? Your signed syllabus? Do you remember when you joined the class there was a salmon-colored syllabus? The last page of that needs to be signed by you and your parents. So I think it's probably this one right here. Nope. You did, but your parents still need to. So remember, take this home, get this signed. When you turn that back into me, you'll get your strip of hall passes. If you don't use those hall passes, those turn into a homework pass. So it's important that you bring that back to me, okay? Okay, homework and notes. Let's talk really quickly before we do the rest of the notes here about homework. This is our first homework assignment that you're getting back, so I want to make sure that you're clear on a couple of things. We have talked about the spelling, correct? Okay, and so remember that even if you get 100 on your paper, you want to check and see, did Miss Lashley remind me that I'm not spelling something right? I didn't use correct grammar or correct punctuation or something like that. And then remember that the first few homework assignments, you're just kind of getting used to what to expect. So don't stress out if your grades aren't perfect at the beginning. And keep in mind that you can always earn those homework passes as we go. And then at the end of the semester, if you had a couple bad grades at the beginning, you go back and you change those hundreds with your homework pass, okay? If you have questions on the homework, we won't take time in class on a daily basis to go over homework questions. But if we ever have time, like hopefully we will today, for you to work on your homework, then you can ask questions at that point. You could say, hey, Miss Lashley, I pull your homework back out and say, I didn't understand what I did wrong here. You get to start going to Encore tomorrow, so you can request Encore starting all next week except for Mondays. So Encore is another great way. Come into Encore, pull out your homework, tell me I don't understand what I did wrong. Or always before school at 8 o'clock. And then the other amazing thing, we got approval finally today from central office that we will now start tutoring like we always do. So we will have free tutoring starting next week, Mondays and Thursdays after school until 4:45. So if after school is good for you, go to tutoring. The signs are posted outside the rooms on where to go. And then on Wednesday mornings, if mornings are better for you, bright and early, you can come hang out with me at 7 o'clock in the morning. I will be here at 7. So come on up and I'll help you with whatever you have questions on, okay? Mondays and Thursdays probably won't be me, except on a rare occasion. Coach Sharp will probably do one of those days, and I'm not really sure who's doing the other one. But it will be somebody who knows how to do geometry and will help you, okay? So homework papers are coming back, and I haven't passed out sticker sheets yet, have I? Okay, so everybody's going to get an index card. If you made 100 on your homework, take your sticker off, put it on your sticker card. Make sure you put your name on the back of your sticker card just in case you lose it. Maybe somebody will turn it in for you because I won't replace your stickers if you lose them. What happens once you get 5 stickers? Okay, it turns into a homework pass. Remember, you cannot use your homework passes until the end of the semester, though. Okay, so, Mr. Caleb, back here, still learning names, bear with me, back to the back, Veer, Malin, right, Malin, Spencer, Andrew, Kelsey's back here, Miss Faith, you'll pass that back to Faith, Riley, back to Emily, and Sydney, do you want to pass it back at the same time? Savannah, Kaylin's back here in the back. If you'll pass it back to Kaylin. And Ohm. And Levi. So Caleb, whenever that day that you wrote, okay, is that what you did that you just forgot to turn it in? So this is one time. I'll take it from you if you want to give it to me, but from the future I won't. So just know that that means if you want to staple it to it and put it back in the tray today, I'll take it, okay? So you're going to take that sticker off, you're going to put it on that index card I just gave you, and you're going to collect them. And as at the end of the semester, however many you have, for every 5, you'll get to pick the worst homework grades you have and go back and change those to hundreds. Okay. Just put it anywhere, and you'll just keep collecting them on that sticker sheet. Just make sure I can see, like, don't put them on top of each other so I can actually count them as we go, okay? Okay. Sorry. Are we all good? Okay, coming back. Notes. So here are your 1-5 notes. Well, it asked for which streets intersected at that point. So you were supposed to name the 2 streets that intersected to form D. Okay, you're welcome. Thank you. Okay, back to our notes. So I'm going to go pretty quickly through this first part because we've already talked about it. So make sure you're with me, listening. Perimeter, here's your definition. Again, it's the sum of the side lengths. Area, definition, is going to be the number of non-overlapping. So you don't want your shapes to be, you don't want to count things that overlap twice. You just count it once. So it's the number of non-overlapping square units of a given size that cover your figure. And so that's what you were saying. It's inside the figure. It covers the figure. It's the number of square units. And what they mean by non-overlapping is just simply if you had something like this, you wouldn't count this part of the circle and count it as part of the triangle. You would only count it once. So either it's part of the circle or it's part of the triangle, but you don't count it twice. Does that make sense? Okay. Here are the formulas for the rectangle, the square, and the triangle that are written on the board. So they're already right there in your notes. They are the same as what we looked at on the board. The only difference, there's a couple of differences here. This is how we wrote it on the board. This is also how you could write it if you just pulled out that GCF of 2. And then we wrote 1/2 base times height. Some of my students prefer to write it as base times height divided by 2. But it's the same thing, so however you prefer. Okay, we talked about base and height, but I want to one more time clarify this. Your base does not have to be the bottom. Base can be any side of the triangle. Any side. What matters then is where you draw your height. Your height is a segment that goes from a vertex and forms a right angle with the line that contains the base. Now that's wordy. Let me show you what that means. So, for example, if you have a right triangle, you could call the bottom the base. The height has to make a right angle with it. It has to go from the vertex straight down, make a right angle. Or you could call this side the base. But if you do, then this is no longer the height. Your height would go from the opposite vertex perpendicular to your base. Does that make sense? Okay, so it can be any side, but if you pick that side, you have to make sure that you know the perpendicular distance that goes to it. If you don't know that perpendicular distance, you can't use that as your base because then you wouldn't be able to calculate your area. Or, for example, you could have this kind of a triangle where your height's inside your triangle versus on the side of your triangle. And you can have a triangle that's obtuse. Be really careful. Are the dashes part of the actual triangle? No. So if we're talking perimeter, we're just adding these 3 sides together. Okay, not the part out there. If we're doing area, we could call this little piece the base, but then the only way to get the height from this vertex over to this base is to extend out the line. That's why it says line containing the base. So you extend out the line and then you can draw in that perpendicular height. Does that make sense? Nope. Any triangle you draw. So let me draw one like, see if I can do it differently. Let's do this. Okay, so let's say that I call this the base. Is it possible to draw a line from this opposite vertex over to this base and make a right angle? No. So what this means is you extend out your base and then you draw the line from that vertex straight down. And that is now the height of your triangle. You use this distance for your base and this distance for your height. Does that make sense? Okay. So your height can be inside your triangle, outside your triangle, or even on your triangle. It just depends on which side you're calling your base. Okay, we already said this. Yes, ma'am, Kaylin. No, you use only the base of the triangle, the side of that triangle. Just that green section is your base length. Your height length is just this distance until it gets to that line. This little part is not used at all. It's just an extension of the line. Okay, good question. All right, we already said perimeter is just going to be units, like inches, feet, miles, meters. Be careful, M stands for meters, MI stands for miles. Area is going to be units squared. So like centimeters squared, inches squared, miles squared, meters squared. Okay? Any questions there? All right. So then we have some simple problems, and then we have some harder problems. So what I want you to do is go ahead and try these next two examples that are in your notes, you and your partner, see if you can answer them. The first one's pretty easy. The second one makes you use some algebra. But really quickly, in my daily pre-AP geometry class, when they had their homework on this, several students didn't read the directions carefully and missed a point on every problem. What do the directions say to do here?
Area and
Perimeter and area. Be careful that you're reading the whole entire question. So on each one of those problems, you should have two answers, okay? All right, go. Let's check and see how you at least did on the first one. So this one should have been super simple. Perimeter, area. Here's some advice, though, if I were you. If you don't feel like you have these formulas committed to memory, or even if you do, it might be helpful to write them down every time you do them on the homework, just because that will help you memorize them even more so. So if this is a what shape? Rectangle. What's the perimeter formula? Careful, 2L plus 2W. Remember that you are always adding the sides together. What's our area formula? Okay, length times width. All right, so we're going to find our perimeter and our area. The length of the shape is what? 6, and the width is 4. So what did you end up with when you multiplied those and added? 12 plus 8 is 20. And our units? Inches. Make sure you identify whether your answer is the perimeter or the area. So put P equals or A equals. Make sure to include your units and circle your answer. Okay, go to area. What's the length? 6. What's the width? And multiply. What do you get? And what are your units? Inches squared. And again, make sure you identify if it's the area or the perimeter. Don't just write two answers. Make sure you identify which one's which on your homework. Okay, that should have been pretty simple. You did that way back even probably in elementary school. Let's move on to where we throw in some algebra. Perimeter and area. So now I have a triangle. There's really not a special formula for perimeter of a triangle. You just add all the sides. So we're just going to add all these together. X plus 4 plus 6 plus 5x. When you combine like terms, what do you get? 6x plus 10. Now, two things. One, did it say solve for x? No. I could make this problem a lot harder by telling you that you had to solve for x. What would you have to use if I made you solve for x? Pythagorean theorem, a squared plus b squared equals c squared. And then you would end up, if we did that, with a quadratic equation, which you would then have to factor or use the quadratic formula or complete the square. I am not making the problems in Chapter 1 that hard right now. So on the homework, if you have expressions around your picture, then you're going to have expressions in your answer, okay? You do not try to solve for x or divide or multiply. You just combine like terms, and then you're done. Second thing, if there are no units, my rule is if there are no units, you don't have to write units. If there are units, you have to put the units. If you like to write the units and there's not any, then you could either put U or units. Okay? But if they give you specific units like inches or centimeters, you can't put units. You have to put inches or centimeters. Okay, let's talk area. What's the formula for a triangle? 1/2 base times height. What's the base? What's the height? X plus 4. Okay, order of operations. Just multiply from left to right. What's half of 6? 3. And we're still multiplying that by x plus 4. So what do? Good. Distribute. 3x plus 12. We'll pick up from there when we get back from lunch. We went to lunch. I want to make sure, first of all, that everybody understood why that was 3x plus 12. Yeah. And that when you substitute something in, you should always put it in parentheses so that you remember to distribute. Because if you don't, you'll get it wrong. Okay, here's the one thing I also want to point out. There were no units given. The most common mistake I see and that I end up counting off for, and I've already done it in my double-blocked pre-AP class, is students will have a problem where there's no units given in the problem and they find out that their area is, let's say, 27 and there was no units. So they do this. And that is wrong. That means 27 times 27, right? And that's not what we mean. We mean the area is 27. What's squared? The units. So make sure that you put a unit, U or units or something, or leave it off. You don't have to if there's no units. If there are units, you have to put them. But if there are no units, my rule is you can leave them off, or you can write U or units, whatever you want to do, but you don't have to, okay? Just don't put the little square, because if you do that, then I'm going to count your problem wrong, because 27 squared is totally different than 27, okay? So just be really careful. All right, and again, identify that it's the area, not the perimeter, when you have two parts to your question. Any questions on those? Yes, sir.
I have a problem, and what if it's a double, like algebraic, like the base is also algebraic, we have to solve each.
So that's similar to the bell work problem that we did the other day. Didn't I put up a problem in here as well that was like x minus 3 squared? Okay, so if you had something like this, is what you're saying, right, like x plus 3 and maybe x minus 2? Okay, so if that's the case and you're doing area, you would say area equals x plus 3 times x minus 2, and then you would use your distributive property to distribute and then combine like terms. Does that make sense? And then again, you wouldn't be solving for x, you would just simplify and that would be your answer. Good question. Any other questions? Okay, and you will highly likely see something like that on your homework. That's why I put that up for bell work, to make sure that we were good with that before we got to this section. And you may also have to use Pythagorean theorem on this section. There is a couple challenging problems on this section on the homework. So again, when we get some time, hopefully you'll get some time to work on that. This part is exactly what we talked about over here. You guys knew all of those words. You knew all of the things that I listed up here. So here are your vocabulary words. Diameter, it's going to go through the center, touch both sides of your circle. Your radius goes from the center to one side of your circle. And the circumference is the distance around the circle. The only thing that's not listed on this slide that is listed up here is that the diameter is twice the radius. So if you want to jot that down just to remind yourself, the circumference and area formulas are on the next slide in your notes, so those are on there. Any questions about that vocabulary? Okay. So again, here's your circumference and your area, and they do list both of the formulas, like we talked about, for circumference, and then your formula for area. Just be careful if they give you the whole diameter, what are you going to have to do before you plug in the value for the radius? Divide it by 2, right? If they give you the whole diameter, you'll divide it by 2 to get the length of the radius. Okay, here is my rule from here for the rest of the school year when it comes to pi, okay? We will never use 22/7, which is approximately pi. We will rarely, I mean on the most rare occasion, will we ever use 3.14. Okay? And the only time I would tell you to use 3.14 is if it was a multiple choice question and the question specifically said use 3.14 for pi. Because then you wouldn't want to use the pi button on your calculator if you're trying to match your answer to their answers if they said use 3.14. Does that make sense? But my rule is I don't want rounded answers unless the directions say to round. I want exact answers. I want us to stay precise. When you get into higher level math or you're really out there designing a bridge, building something, you can't round all along the way and have rounded estimated answers, or then the real product is going to collapse and not work because you're going to be far off from your actual values. So the best thing to do is try to stay as exact as possible throughout your work. So we'll never round until the very end of our problem. We'll keep our exact values all the way through until the end, and then we'll follow the directions in the book. If the book says round, you're going to round, but wait till the end. If you're working with pi, you'll plug pi in on your calculator and then round according to the directions, okay? So don't use 3.14, don't use 22/7, use your pi button on your calculator. There will be some problems and you may have to round on the homework, and I know I said that this is no calculator for a semester, but then also there are some harder problems on the homework sometimes. So we'll use our calculator on homework when we get to those bigger numbers or when we have to round. On the test for Chapter 1, I will not have you plug in pi and round because you won't get a calculator. So what we're going to do is we're going to look at problems like this, and we're going to practice for the test, but we're going to follow the directions in the book. So for the test, what it's going to say is leave your answer in terms of pi. So on the test, you're not going to have a calculator, so you're going to do all the math and then leave pi in your answer. Does that make sense? We'll practice it that way in the notes. On the homework tonight, though, you're doing whatever the textbook says. If it says leave it in terms of pi, leave it in terms of pi. If it says round, plug it into the calculator and round. Are we good with that? Okay. On the calculator, does everybody know where the pi button is? Okay, if you don't know, you can either grab out your calculator if you have it with you, your phone if you're planning to use your calculator on your phone. You can jump up and grab one of my calculators to look and see if you have a calculator like that. Whatever you're going to use for a calculator. If it's your Chromebook and you want to look on it and you're going to Google calculator, do that now, or I'll show you on mine as well. But make sure you know where the pi button is right now so I can help you if you don't know. I'm assuming everybody has access to some sort of calculator at home. If you do not, see me before you leave class, okay? It does not need to be a graphing calculator. If you have a cell phone, most of the time on your cell phone, your calculator, if you turn it sideways, turns into a scientific calculator and it has the pi button. On these calculators, when you're looking for pi, where is the pi button? It's in blue, and it is right below the word clear. It is above this little caret symbol. Does everybody see that? And so that means we have to hit the second button, and then we hit the pi button. Okay? So the little caret button has pi up above it. Worst case scenario, if you don't have access to a pi button at home and the problem says round, you could do every bit of the homework, work it all out till the very end, and then come in here at 8 o'clock in the morning, and on the few problems where you need to round, you could grab a calculator quickly and type those in and then round it and circle your answer. And you would have it done before it was due that day. There won't be enough where you would have to, spend 30 minutes doing that. Or Encore tomorrow, or on Monday you could, well, Monday you can't come to Encore, just kidding. But any other day of the week you can. Are we good? Okay. So, look at your question here. Find the circumference and area of a circle with a radius of 8. Use the pi key on your calculator, then round to the nearest tenth. So what formula will I use for circumference? Say it again. Okay, I could use diameter times pi, which is fine, but they don't give me the diameter here. So if I'm going to use pi times diameter, what am I going to have to do to find my diameter? Multiply the radius by 2. Or I could use the other formula, 2 pi r, and plug in the 8 for the radius, right? Okay, if we're leaving our answer in terms of pi, this is not how you leave your answer. You can simplify that. What does that become? 16 pi. Treat pi like you would a variable. You would never say x 16. You always say 16x, right? So it's the same with pi. Don't put pi in front of your number. Put it after your number. Treat it just like you would a variable all the way through your math. Treat it just like a variable until you're ready to type it in on your calculator. So it has the same rules as it would if it were an x. 16 pi, and then don't forget your units. What are the units? Centimeters. Okay, if you have your calculator in hand, somebody type that in and tell me what is 16 times pi to the nearest tenth. 50.3. So to the nearest tenth, we'll put 50.3 centimeters. That's our circumference. Circle our answer. Don't forget your units. Last part of the problem and last thing for the notes. Area. What's the formula? Go for it. Pi r squared. Say it again. Okay. And then what am I going to plug in for the radius, Faith? 8 centimeters. And I will tell you that your physical science, chemistry teachers, they will appreciate it if you are getting good at working with your units. If you put them in your work, it's going to help you a bunch. I'm not going to require you to do that. But if you type in or put in 8 centimeters, notice that you're squaring the 8 and you're squaring the centimeters. So it just reminds you that your units should be squared. So that when you get to chemistry and you're working with all different kinds of units and some of them are canceling out and some of them are staying, it'll help you practice with that skill. Okay, what is 8 squared? 64. So what would my answer be here without a calculator?
64 pi centimeters.
Very good. 64 pi centimeters squared. So again, if the test says leave your answer in terms of pi, that's how you're leaving your answer. If the directions in the textbook tonight say round to the nearest tenth, you're going to plug that in on your calculator. Very good. 201.1 centimeters squared. I'm going to emphasize again, tonight on the homework, what are you going to follow? The directions in the book. I said that in my double blocked pre-AP, and I don't know what happened, but a couple of people in there didn't follow the directions in the book. They left all of their answers in terms of pi, and so then they missed a little bit on every problem because they didn't round correctly. So make sure that you're doing the directions in the book. The only reason I emphasized in terms of pi is so you'll be prepared for the test. So if I were you and I'm doing my homework, I would try to practice leaving it in terms of pi before I round it according to the directions in the book, just to make sure that I'm ready to leave my answer like that for the test. But do what the book says for the homework, okay? Hopefully I've said that enough. All right, any